Hello, welcome back to Lesson 7, Analyze and Graph Data. So today we're starting with a little bit of a different layout. Here I have the questions on the left and I've created this little template of a graph on the right. So now if you look at the question, we have all this information here about third graders and fifth graders and events. And we're also seeing make a bar graph for each grade to compare the data for the two classes. Keyword here being bar graph. Now I've already set up a part of the bar graph, and that is I set up what events are happening here, which is bobsledding, ski jumping, figure skating. And I also have the scale on this left side, which indicates the amount of third graders or fifth graders. So in this case, I did not write it out, but it will be students. Let's just abbreviate. And now they want us to make two separate bar graphs here for each grade. So let's just start with third graders. For bobsledding, there's 17 third graders that are interested in bobsledding. So I'm going to draw that in up until right around where I hit 17. I'm estimating here because I made my scale in 5s. Imagine that this bar here is colored in, despite my pen being very, very thin. And so that's what it will look like for bobsledding. Now for ski jumping, it'll be similar, right under 15, not all the way until 15. Again, let's fill this all the way out. Then for figure skating, again, right under 10, which will be somewhere roughly here. This is the completed bar graph for grade 3. Now for fifth graders, we can do the same thing, but just simply change the bars that we made. So I already just erased it for you. And now we can just look at these numbers and put them in. So there's 15 for bobsledding. So we're going to put that right up to 15. Again, pretend this is filled out. And for ski jumping, we have 16. So just a little bit more, right? That's a little bit higher. Pretend this is filled in once again. And figure skating, which has 10. So that's going to go right up to that 10 mark. Excuse these bars for not being perfect, but they should be if you were modeling them on a spreadsheet or whatnot. There you go. That is what it will look like for fifth graders. Now let's look at the second question. Make a double bar graph to compare the data for the two classes. So this time, we're doing almost the same thing as question 1, but it's a double bar graph. This means we can include both third graders and fifth graders in one bar graph. So let's do that right now. So we're going to do exactly what we did, but we're just going to put the two different values for both grades side by side. So I'm going to start with third graders. For bobsledding, again, 17, but I'm going to put it to the left a little bit and a little bit skinnier. Okay, and 14 for ski jumping, right around here. And 9 for figure skating, so right around here. And then I'm going to go back and look at the fifth graders, and there's 15 for bobsledding, so right around here. And you're going to put it right next to that original bar I made. And 16 for ski jumping, so it's going to be higher this time, right? But right next to that bar. And 10 for figure skating, so again, slightly higher and up. This is what it should look like. Again, imagine all these bars are colored in just like that. And this is how you make a double bar graph. Now, which graph makes it easier to compare the data for the two classes? Explain. So, if you think about it logically, it would be easier to compare third graders and fifth graders if you're looking at the bars side by side like this, right? If you only have one bar for each, you can't really see both types of grades in that one graph. So you would want to have the double bar graph for this type of question. So I will shorten it as a D bar graph. All right, and we're back to our normal format. Between which 2 hours did the mass of bacteria increase from 10 to 12? So now when you're looking at this, we know that hours here is in the x-axis. This horizontal plane is called the x-axis. And we know that the mass of bacteria here is the y-axis, which is the up and down. So what 2 hours, meaning x, did the mass of bacteria, y, increase from 10 to 12? So we want to find these numbers on the y-axis. So where's 10? Let's see, there's 4, there's 8. Okay, 10 is right here. And where's 12? This is like 11, this is 12 right here. And now we want to find what hours correspond to these masses. So you can go straight down to find the x-axis. And we see 2 here, which represents 2 hours. And we see 0 here, which represents 0 hours. So the 2 hours that the mass of bacteria increases is 0 to 2 hours. This is your answer right here. Now for question 2, what is the mass of bacteria on hour 5? So now we're given the x-axis value here, which is 5, and they want to find what is the mass of bacteria. So to do that, which means finding the y value, you just want to go straight up until you hit it right here, and you realize the y value here is in between 28 and 24, which is going to be 26. So it's 26 milligrams. Can you conclude that more first grade students like dogs and fish than do third grade students? So under first grade students, we see that 7 of them like dogs and 9 of them like fish. And for third graders, 9 of them like dogs and 7 of them like fish. So if you do the adding here, this is 16 and this is also 16. So no, you can't. Why? Because they're the same. The values of the first grade students and the third grade students liking dogs and fish are the same. So I can't write all that out, but that is your explanation. Now for 2, create a conclusion that could be supported by the table above. So for this just means say anything that's true based on this data here. So I'll just give you an example. Third grade students like cats more than first grade students. That's true. You know why? Because 5 is more than 3. Another thing I can say is first grade students like dogs less than third grade students because 7 is less than 9.